Okay, so today we are going to begin with a new topic. We completed triangles yesterday. Today we are going to start with quadrilaterals. Okay, so basically, the name itself suggests quad. That means four. So any figure with four sides or four angle can be considered as a quadrilateral. The first property that I can tell you about quadrilaterals is, so suppose this is a quadrilateral, okay, A, B, C, D. Let's say this is a quadrilateral, and if I join these two diagonals like this, right, A, B, B, C, C, D, and D, A are sides of this quadrilateral. While if you see AC and BD, these are diagonals of this quadrilateral. Okay. I don't think this is visible on the screen. I think there's some issue with my screen sharing. Let me share that again. Okay, yeah, now it should be fine. So as I was saying, that your AC and BD will be quadrilateral, will be diagonals of this quadrilateral ABCD that you have. Now let's say these diagonals, that is AC and BD, form a theta angle with each other. Okay. In that case, you can find area of any quadrilateral. And how can you find area of any quadrilateral? So what we are going to discuss, we are going to discuss properties of quadrilaterals. This is something we are going to discuss. And as for the first point that we have, area of any quadrilateral at all. So whether it is a square, rhombus, kite, rectangle, anything at all. Area of any quadrilateral can be given by half d1 d2 sine theta. And d1 and d2 are the lengths of the diagonal. d1 d2 lengths of diagonals. Okay. Now coming to second point, in which we are going to discuss between rhombus and kite. Okay. Now in rhombus, if you see, it is a figure like this. Okay, a square kind of a thing. But in square, all the angles are 90-degree. In rhombus, that is not true. Okay, so all the sides are equal. Like if this is A, this is A, this is A, this is A. So that is true. But these angles that you see, these may or may not be 90-degree. Okay, so that is something that you can remember about rhombus and how they are different from square. In square, all the sides are equal, as well as all the angles are equals to 90-degree. Now, this is a rhombus, and kite looks something like this, in which adjacent sides are equal. So if this is A, this is A, this is B, this is B, something like this. I will here also I'll make the diagonals, which would look like this. Now, in kite, only one of the diagonal is bisected. That means this particular will be equal to this particular that I have mentioned with a single line, single black line, as you can see. So these two will be equal. So only one of the diagonal is bisected. While in rhombus, both the diagonals are bisected like this. And they are bisected at 90 degree. That is another property. Let me write down a few things. Diagonals bisect each other at 90 degree. In this case also it is 90 degree. Okay. In kite, only the larger diagonal bisects the shorter diagonal, right? So only the shorter diagonal is bisected. One more point that you can write is rhombus is basically a parallelogram. Rhombus is a parallelogram with all four sides equal. Okay. While in kite, adjacent sides are equal. So this you have in both of these. Rhombus is a parallelogram in which all sides are equal, all four sides. In kite, only adjacent sides are equal. Okay. Area of rhombus can be given by half d1 d2. Okay. Because if you write for sine theta that is sine 90 since they are bisecting at 90 degrees, so theta will be 90 and sine 90 is 1. So you get area of rhombus as half d1 d2 multiplied by 1, that is half d1 d2. Also in rhombus, opposite angles are equal. Opposite angles are equal. That is, this angle will be equal to this angle and this angle will be equal to this angle. I'm not sure if you can see that. It is very light, but I'm referring to these angles. Angles of rhombus. Okay. Here, one pair of angle at vertices get bisected. This is also one point. Okay. So on the longer side, you can see here this angle and this angle is bisected. Here, I'll just make it a bit dark so that you can see. I mean bold so that you can see. Okay, so these two are bisected. I'm just writing down the points that will come very, very handy. And again, same thing for kite also. Area of kite can be given by half d1 d2 because again in this also diagonals are bisecting at 90 degree, right, or intersecting at 90 degree, not bisecting, they're intersecting at 90 degree. So sine 90 will be 1 and you will get answer as half d1 d2. Okay. Also one more thing if you observe is this triangle is mirror image of this triangle. And that is why I said that particular angle will be bisected, so that this angle will be equal to this will be equal to this side is equals to this diagonal is equals to this side is equals to this. So they are basically mirror image of each other, right? Everything down the line over there. Okay, so this was the second point that I wanted to discuss, which is the difference between a rhombus and kite and what are their different properties that you should know. We will keep coming back onto this, but yeah, for now this should be okay. Let me tell you about third thing in any quadrilateral. So I'll write that down in any quadrilateral just in case. This is the quadrilateral. Okay. And these are the diagonals. All right. This is A, this is B, this is C, this is D. These are areas. Okay, I'll write that down also. That A, B, C, D are areas of respective triangles. Okay, so A is the area of this, B is the area of this, C is the area of this, while D is the area of this. Okay, now in any quadrilateral and always A multiplied by V will be equal to C multiplied by D. Every time, always, this is going to hold true. Remember that. Okay. If you have any question, any doubt, let me know. In this thing, in rhombus and kite, or in this particular area formula that we just got. Okay, so the opposite sides you can see, opposite triangles that you can see, right? Their multiplication will be equal. Cool. Let's give you a question and let's see if you can solve it. So let's say this is a quadrilateral and these are the areas, A area, B area. The area of this is 27, this is 12. Then find the minimum area of this quadrilateral. Chalo, you have 1 minute. Try to solve it. And if you have answer, please let me know. Okay, let's see. We just saw this formula where multiplying the opposite triangles makes the area is equal. So I can write A multiplied by B equals to 27 multiplied by 12. That is 324. Since we need minimum value, so from the concepts of number system, we will make A and B equal to each other, which will be A square or B square, whatever you want to call it. This will be equal to 324. So A will be 18, taking root on both sides. So the minimum area will be 18 plus 18, that is A plus V, then 27 plus 12, so this makes it 39, 36, which is 75. And that is your answer. Okay, let's have a look at another property. If there is any point inside a rectangle, remember, specifically rectangle I'm talking about. I hope you know what is a rectangle. Rectangle is a figure like this in which opposite sides are equal. Okay, and the sides meet at 90 degree. This is a rectangle. Now, as I was saying, that let's say if there is a rectangle and if there is any point inside a rectangle, let's say this is that point. Okay, and let's call this P point. So now if I join all the vertices with this, so like this, something like this. Yeah. And let's say these sides are, this is A, this is B, this is C, this is D. In that case, A square plus B square, that is length of AP plus length of PC, and the square of them will be equals to C square plus D square. And this is called British flag theorem. Right? This is the result of that theorem. That is British flag theorem. Okay, so let's quickly give you a question and see if you can solve that. Let's say this is the rectangle that we have. This doesn't look like a rectangle. Yeah, this is A, B, C, D, and this is a point P over here. Now PB is given as 10, PC is given as 12, AP is given as 15. Then what will be PD? Come on, you have 30 seconds. Try to solve this. After this, we are going to discuss a bit about parallelograms and then trapeziums. Okay, let's solve this. So we just saw this British flag theorem. So that is only we are going to apply. So I will write PD square plus PB square equals to AP square plus PC square. PD square, we don't know since we have to find. PB is given as 10. AP is given as 15. PC is given as 12. So this would be what? PD square equals to 144. 12 square plus 15 square is 225 minus 100. So PD square will be 125, 25, 44, 69. So that is 269. So PD will be root 269. And that would be your answer. Root of 269. All right. Let's talk about now parallelograms. Understanding parallelograms is fairly simple. Parallelogram looks something like this. Say this is A, this is B, this is C, this is D. In this, opposite angles are equal. If this is theta, and this is 180 minus theta, and this is 180 minus theta. So adjacent angles are complementary to each other. Okay. Also, AB is parallel to CD and AD is parallel to BC. And that is how your parallelogram looks. I will write it down here also. Opposite sides are parallel and equal. Okay. If you want to know the examples of parallelogram, then look at a square, rectangle, or a rhombus. Right? These are all part of parallelogram family only. So look, if you have a square, right, all the sides are equal. Doesn't matter. In parallelogram, you just need opposite sides equal. So that is fulfilled. Also, lines are parallel. So that is also fulfilled. Right? So this is one property. Second, in any parallelogram, okay, whether it is a square, rectangle, rhombus, or parallelogram itself, diagonals bisect each other, that they cut each other in half. So if I join AC and BD, AC and BD will bisect each other. Third point, adjacent angles are complementary angles. So I'm just now writing whatever I have drawn in that figure. Let me draw one more thing and then we'll be better off. So if I write it like this, okay, there's this. Now whatever is in that figure only I'm writing. Opposite angles are equal. That also I have made in that figure. Now one thing, since let's say this is point O, okay, the point where they bisect each other. Now since diagonals bisect each other, therefore BO will act as a median, right? So now O will be midpoint of AC. So if that is the case, that means BO will be median for the triangle ABC. Similarly, O will be midpoint of BD. So AO will act as median for ABD and CO will act as median for triangle BCD, right? And other triangles you can draw and find out. So basically what I'm trying to say is if that is the case, then we can apply Apollonius theorem here. And if we apply Apollonius theorem in triangle ABC, triangle ABC, if we apply OA square plus OC square will be equal to AB square plus BC square. This is the result that we wanted. Another property. In any parallelogram, very important point, okay? Sum of square of diagonals is equals to sum of square of all four sides. That is AC square plus BD square equals to AB square plus BC square plus CD square plus AD square. So remember that in any parallelogram, okay, sum of a square of diagonals is equals to sum of a square of all the four sides that you have. One more. Area of any parallelogram is equals to B multiplied by H. Again, very, very important property. So let's say if you have this parallelogram like this, okay, this is A, this is B, this is C, this is D. And here you have perpendicular E. So area will be AE multiplied by DC. Why B into H? Because you see, this basically forms two triangles. If you look for triangle ABD, so it will be half, height is AE, base is AB, right? And if you look for triangle BCD, in that case, height is still AE and the base is DC. But since opposite sides of parallelogram are parallel and equal, so AB will be DC. So half half will make 1 and it will be AE multiplied by DC, which is our original answer. That is base into height. Or we can keep it whatever you like. One more property. ये समझ में आ जाए आखिरी प्रॉपर्टी है तो बहुत अच्छी बात है. In any parallelogram, angle bisectors form a rectangle. How? Let's see. Let's say these are the two lines. Then it forms a parallelogram. Okay, this doesn't look like a parallelogram. This does. Now, angle bisectors. So that means something like this, because diagonals do not bisect, right? So if this is one, then this is another for this angle. Then we will need for this angle as well. So it will go from here. Then we need for this angle also, and it will go from here. So the triangle that is formed here, that you see, this is a triangle. Remember that. Theta, theta, obviously, 90 minus theta, 90 minus theta. So this will be 90, क्योंकि इस triangle में 180 total करना होगा. This is 90. So this is 90. Vertically opposite angles. And that makes it a triangle. Right? That's 2 theta, 180 minus theta. Sorry, 180 minus 2 theta. ये एक प्रॉपर्टी है जिस पर कभी कभी क्वेश्चन आ जाता है. So I thought that I would tell you. If you have question in any of the properties, then you can let me know. Otherwise, we will move on to trapeziums. Any question, Surya and Mansa? Or are we good? Is everything clear? Okay, Surya, is everything good? Perfect, perfect. All right then, let's move on to our next quadrilateral, that is trapezium. Trapezium is very interesting because it is different also from other quadrilaterals. Unlike others, we have just discussed mostly parallelograms right now, right? And trapezium is not a parallelogram. Let me draw a trapezium. Here you go. This is a trapezium. In this, these two lines are parallel to each other. That is the only relation that you have in a trapezium, that you can say that, okay, there is some relation. This is the only thing that you can talk about. Let's write down some points. As I said, one pair of side is parallel. Now, let's discuss some fictional points or points based on some condition. If AD is equals to BC, That is non-parallel sides are equal. If that is the case, then it is called isosceles trapezium. Okay, if AD is equals to BC, then it is called a isosceles trapezium. Or if in question it is given that you have a isosceles trapezium, then you can assume that AD is equals to BC. Now, let's say E is the midpoint of AD and F is the midpoint of BC. And AG is the height of this particular trapezium that we have. Since this is a midpoint, so this is equals to this and this is equals to this. Then EF is equals to AB plus DC by 2. Okay. If E and F are the midpoints, remember that there is a condition for that. That is why I have written these, right? I have drawn these. Now, area of any trapezium can be given by half into sum of parallel sides multiplied by height. That is half multiplied by AB plus CD multiplied by AG. This is the formula for the area of any trapezium. Chalega? Let's move forward. Let's again draw that trapezium. Let us join these. Now, in this case, since AB is parallel to CD, so this angle will be equal to this angle, and this angle will be equal to this angle. And this angle vertically opposite will be equal to this angle. So you see, all the angles are equal somehow in both these triangles. Let's say this is a point O, then triangle AOB will be similar to triangle DOC. So the ratio of the corresponding sides will be equal to each other. This also you can remember. Also, sum of square of diagonals will be equal to sum of non-parallel sides and 2 times product of bases. That is AC square plus BD square is equals to AD square plus BC square plus 2 times that of AB and CD. And this is also something that you get. Okay. Last but not the least, a seventh property of your quadrilaterals which is very, very important. I'll mark a star as well above this. Any random quadrilateral, if midpoints of adjacent sides are joined, then the figure that we get is a parallelogram. Let me show you. Let's say this is any random quadrilateral that you have. Okay, just a random quadrilateral that you have. Let's call it A, B, C, and D. But if you join midpoints of all the sides, then you get a parallelogram. Look, even I drew a very random diagram, right? It does look like a parallelogram, and that will always happen. Now, if you have any question, if you have any doubt, let me know. These are all the properties that you need to know in order to work with quadrilaterals. There might be a few more. I don't think so, but if there are any more, then you will get them once you solve more and more mocks. And if in any question you find them, then you can note it down. Otherwise, I think that these are the most of the properties that are there. At least I can say 95% or 98% of the properties I have covered. So you can easily go into the CAT with these properties of quadrilateral that I have just provided. All right. Any doubt? Any question? No? All good? Okay, let's solve some questions now. This is a rectangle. The length is 40. The length is 50. And the question is, what is the maximum parameter of a quadrilateral that can be cut out from this rectangle with all four sides equal? This is the question. Try to solve this. See if you can get it. Clues are already given, I guess. You can see that it says all four sides of the new quadrilateral that we need should be equal, and given figure is a rectangle. So given figure is a rectangle. Here, this is 40, this hole is 50. Now look, all four sides of the new quadrilateral should be equal. That we need to find out. So let's say this is A, this is B. Okay, no, we don't need to mark these. Let's say from this side, we are cutting till here. And let's say this is X. Okay. And since we need all the four sides to be equal, so I will try to take it like this. No, video is not stuck. I am speaking. Mimansa, can you see things moving on the screen? Like I'm drawing dot, dot, dot now. You can't. Okay. Let me reshare in that case. Okay. I hope it is visible now. Is it visible now? Okay, perfect. So let's say this length that we have taken, this is X, and since all the sides needs to be equal, so let's say this is also X, this is also X, and this is also X. So this is the figure that we are carving out from this particular triangle. So yeah, that is how it looks. Okay. Now let's call this is obviously 40, so not call this, but it is 40. Uh, no, okay, so I think I have made some mistakes over here. Yeah. So we can, yeah, we'll have to do this, right? So then only this will be X because this is coming from here till here. So this will be from here till here. So this is X and this is also X. So this is 40, and since this is a rectangle, so this will be how much? X square minus 40 square, applying Pythagoras theorem. This would be root of x square minus 40 square. So now if I add them, x plus root of x square minus 40 square, so this will be equal to how much? This is given as 50. I will take x on that side and I will square. X square minus 40 square equals to 50 minus x square. So this would make it x square minus 1600, and this will be 2500 plus x square minus 100x This would be 100x equals to 4100. So x will be equals to 41. So that would make your parameter equals to 41 multiplied by 4. That is p equals to 164. And that is your answer. Right? Cool. Let's solve another question. What is the radius of a circle that is inscribed in a rhombus with diagonal length 10 and 24? Tell me this. These are given as 10 and 24. Okay, let's try to solve this. So let's say this is the rhombus that you're having, something like this. And this is the circle that is inscribed in it. Okay, let's call this A. And let's say this is one of the diagonals. And this is C. And this is another diagonal. They obviously bisect each other. Let's say this is O. So diagonals are given as 10 and 24. So let's say this AB, CD. So let's say this AC diagonal that you have, the length of this is 10. So this will be 5, this will be 5. And length of BD diagonal that you have, let's say this is 12, this is 24. So this DO will be 12, right? So now, if you see in triangle AOD, can you apply Pythagoras theorem? If you apply Pythagoras theorem, then you will get this as 13. Yeah. Now, once we have that as 13, if I join this is the radius. And I told you whenever you have a circle and you have a line that is AD right now, and if you draw from center to this point, then this is 90 degree. So in triangle AOD again, the area is half, base is AD, that is 13, height is radius, that is R, is equals to half. Again, base in this triangle, base will be OD, that is 12, and height is AO, that is 5. So now R is 60 by 13. Okay. Yeah, that is one thing that you have. Let me give you one more question. This is related to trapezium. Now look, here, here, here. This is parallel to this. Obviously, since this is a trapezium, let's say the length of this is 50, 66, 15, 17. Then find area of trapezium. Chalo, try to find this. Okay, Surya says that the answer would be 888. 14, 196. No, 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 no. Answer is somewhere in root. It's not 888. Okay, let's do it. Since the length, the opposite are equal, parallel, that is the 60 lines are parallel. So what I will do, I will draw these two imaginary lines, right? Perpendiculars to that. Let's assume this is X, this is Y, and this would be 50. So remaining X plus Y will be 66 minus 50. So X plus Y will be 16, or you can say X is 16 minus Y. That's something we will get. One equation. Now look, since this is perpendicular, so we can apply Pythagoras theorem here. Yeah. And this will be equal to this, since they are both perpendiculars from two parallel lines, between two parallel lines. So they should be equal. So in both the sides, we can apply Pythagoras theorem, and we will get 17 square minus y square equals to root of 15 square minus x square. So you have equation 1, you have equation 2, x and y are your two variables. So you can find y and x, and with that you can apply on this. So let's say I think y is 10 that you're getting. I have the results with me. Y is 10. So if you need to find height of this, so height will be 17 square minus y square, that is 289 minus 100, so root 189. Applying the area formula is simple, half into sum of two parallel sides, that is 50 plus 66 multiplied by its height, that is 189. So this would be half of this, 25, 33, 58 root 189. This is the result that you get and the area. Any doubt? Any question in this? You have one equation, x equals to 16 minus y. You have this second equation, root 17 square minus y square equals to root 15 square minus x square. So just replace this x with this value and solve this equation and you will get y equals to 10. Although I'm not sure if you will be getting y equals to 10, I have just written it for the sake of it. Maybe you will get it. I think like in my solution, I can see that not in my solution, but I have this y value here. Somehow it is written along with the question. So I hope that this is correct. Okay. You can try to solve it and find it out. It is written just along with the question. So I just assume that it is the correct value for this question only. But yeah, I mean, if you see it satisfies all the conditions, so maybe yeah, it is true. Right? Because if you take this 6 and you apply it here, make this 6x and you apply it here, then also you get the same height. So I'm assuming that it is correct. Yeah, so those were the 7 points for your quadrilateral. And these were the few questions that we needed to solve. Now your task is to find more questions and solve more questions, right? So do that. Uh, After this, as for the conceptual part, I think we will have around 3 more lectures. We will be done with the syllabus of geometry. I think circles is remaining and mensuration is remaining. These are the two major topics that are remaining, basically polygons and circles. So that we will cover in the upcoming 3 lectures. I think in 3 lectures it should be done. After that, we will solve a few more questions in the upcoming lectures, in 1 or 2 lectures. And yeah, in one more week, you will be done with geometry. Before Diwali, I can assure you that your geometry will be done. We have solved many questions until now, and we will continue to solve them. So yeah, this is it for today. I'll see you tomorrow. I'm here for a few more minutes. If you have any question, if you have any doubt, you can ask.